Today we're going to look at density, which is a combination of two measurements that we've worked with in class already, that being mass and volume. So before we calculate density, we should know some stuff about it. First of all, it's called the derived unit. It's called the derived unit because it's a combination of one or more common measurements. Another example you see in the notes, miles per hour, distance, and time. And then grams per milliliter would be mass and volume. Another idea or topic that we cover when looking at density is that density is a physical property. It's a characteristic that we can observe without making the substance change its chemical makeup. And we talked about chemical change and physical change, so if you need to, please go review in your notes. Some examples of physical property include color, hardness, and of course, density. Density is defined as the amount of mass per unit volume. And its common units include grams per milliliter, grams per centimeter cubed, and kilograms per liter. Now, if I look at these units, I could kind of figure out what the formula is. I have mass over volume, mass over volume, and mass over volume. So if I think about that a little bit, I think I could figure out that the formula for density equals mass divided by volume. So of course, we look up here, and here's the formula for density. But at times, we're going to be given density and volume, and we're going to need to calculate the amount of mass. So if I look at this and I wanted to solve for mass, what would I do? I'd multiply by volume, and volume cancels here, correct? So I get rid of volume. And what I do to one side, I have to do to the other. So mass is going to make volume, and I'm left over here with density. So now, if I think about this, I'm now going to solve for volume if I'm given mass and density. So if I look at the second formula that I've created, and I need to get rid of density on one side and solve for volume, what am I going to do? I'm going to divide by density. And density will cancel. And what I do to one side, I have to do to the other. So if I think about this, I'm going to be left with mass divided by density equals volume. So that's mathematically how you're going to calculate the different variables worked with density. Now we do have a little bit of a cheat here to help you remember. It kind of reminds me of the Triforce in Legend of Zelda. So if we go here, we could fill in the variables into this triangle. And what I can do is I can use this square to cover up the variable I want. So if we work with the first equation and I cover up the d, it looks like m over v, or mass divided by volume. If I want to solve for mass, I cover up the m, and it looks like this formula right here, density multiplied by volume. And if I want to solve for the third formula, I cover up the v, it looks like m over d, or mass divided by density. So we could use this idea right here to help us solve some problems. And that's what we'll do next.
Is this a drill or something?
When solving any problem, what I do is I read the problem, figure out what I need to calculate and what I'm given. So if I read the problem, a block of lead with dimensions of 20 centimeters by 8 centimeters by 3.5 centimeters has a mass of 6,356 grams. Calculate the density of lead in grams per centimeters cubed. Well, I'm asked to calculate the density, so I'm not sure of that. That must mean that somewhere in there I know the mass. And the mass was given to me as 6,356 grams. And I have to be able to find the volume. Well, I'm not given the volume directly here, but I am given three measurements: length, width, and height. So I know that I could get volume by multiplying those. Length times width times height. So what I'm going to do to calculate volume first is I'm going to take 20 centimeters, multiply by 8.0 centimeters, and multiply that by 3.5 centimeters. And if I do that in the calculator here, I take 20 multiply by 8 multiply by 3.5, I get 560 centimeters cubed. Now the neat thing about this is I look at the units of measure that I want. I want this in grams per centimeters cubed. My mass is in grams and my volume is in centimeters cubed, so I don't have to do any converting here. So remember, I can take my little cheat sheet here, cover up the variable that I want to solve for, and it looks like D equals M over V. So now it becomes just a plug-and-play problem. So I have density equals the mass of 6, 3, 5, 6 over the volume, which we calculated to be 560 centimeters cubed. So then I'm just going to plug that into my calculator. So 6, 3, 5, 6 divided by 560, and that's not it. Let's try that again. 6, 3, 5, 6 divided by, not subtract, 560, and you get a density of 11.35 grams per centimeters cubed. For this example, we're not asked to calculate the density, but one of the other variables. So let's read the problem. The density of CCl4, which is carbon tetrachloride, is 1.58 grams per milliliter. What is the mass of 95.7 milliliters of CCl4? Well, if I look at this problem, now I'm asked to calculate the mass of the object. This time that must mean that I'm given the density, which I am, of 1.58 grams per milliliter, and then I'm given the volume, which is 95.7 milliliters. Now the neat thing is here is I check the units of measure. My milliliters are the same unit, so they would cancel, so I don't have to worry about doing any conversions there. And my mass is in grams, and the problem doesn't state which unit of mass they want, so grams would be fine. So now I'm going to take my little cheat sheet here, and I'm going to cover up the M, and this looks like mass is going to be density multiplied by volume. So I'm going to take my units here, and mass is going to equal density 1.58 grams per milliliter multiplied by 95.7 milliliters. Notice the units milliliters cancel. If I do that on my calculator, 1.58 multiplied by 95.7 equals a mass of 151 grams. So again, very easy. Now you can do a check, just plug in mass divided by volume, and you should come up with a density of 1.58, and if you do, you know you've done it correctly.
This is a restricted area.
For our last example, we're going to now need to calculate the volume. So the volume is the unit of measure that I need to calculate. That must mean that I'm given the density, which is 0.82 grams per milliliter, and the mass, which from the reading, what is the volume of 227 grams of olive oil if its density is 0.82 grams per milliliter is 227 grams. So now I have to come up with my plan. So I'm going to use my triangle, cover up the V this time, sorry, not the D, but the V. And to solve for volume, it looks like I need to do mass divided by density. So volume equals mass divided by density. So volume here is going to equal 227 grams divided by 0.82 grams per milliliter. Again, notice what unit is going to cancel. Grams will cancel, and I'll be left with milliliters. So if I take 227 divided by 0.82, I get a volume of, that does not seem right, so let's try it again. 227 divided by 0.82, I see what happened. Let's try it one more time. 227 divided by 0.82, that would get a volume of 276 milliliters. Now you may ask, why would we want to calculate density? Well, one of the things is that we can use density to calculate the identity of unknown objects. And we're going to do this in lab. And why can we do this? Well, it's something called an intrinsic property. It doesn't matter the amount of the substance that I have, I will be able to calculate its density. Then I can compare it to known densities and identify the object. If you need a reminder of that, go back and watch Mr. Carlson or Dr. Carlson's video, which is found on my website. Have a great day.
You know, sometimes I amaze even myself.